Hello, so what we're doing here, um, first of all, if you didn't have the chance, check the divide and conquer for single dimensional arrays that we solved before in this channel. It should be very straightforward. It has a quick explanation, complete explanation on what is the find a peak problem. And after that, you should be able to jump into this exercise more easily. Uh, so what is this about? We also cover on the one of my first videos the MIT algorithms course. Basically, I basically shared this series of lectures from MIT in the introductory lecture. The lecture basically uses single dimensional arrays and matrices to apply divide and conquer strategy basically to reduce time and complexity. And this is usually a good strategy if we want to, you know, if we could, like, for example, if we see like on the problem like something like O of log n or something like this. In this case is O n log n, which we're going to talk about that later. But uh, that's one case that we can apply this strategy, for example. So let's go to the problem. So what's the actual problem? Find the peak 2 here. Um, Basically, find a peak 2 is the same thing as find a peak 1, but on a multi-dimensional array. And what is a multi-dimensional array? As you can see, we have an array here, and we have a series of, we have like three arrays inside this array, basically. For the first item, O, and second item 1, and second item 2. And the first item O, we have 10, 20, 15, 20, and then so on, right? And it renders uh like rows, right? So first row, second row, the third row, um, and that's basically what it means here. Um, where we can access this data structure uh, data by using array methods. For example, to access um, 10, I would say MOO, which is the first item on the first array and the first item of that uh, first item. So and so on. So basically that's the basic, basics, um, of working with matrices, I would say. And that's where we should start thinking on the exercise. um, because basically that's what I did here. I was like, okay, what's a matrix? We're working with matrix, and what is a matrix then? And then I tried to break that data structure down in the board, basically, and that's what I did. So with that being said, we have M, which is the number of columns, and N, which is the number of rows, right? So what's happening here? The find a peak problem states that we want to find a peak on the problem, basically. What defines a peak? Data item that is higher than its neighbors. For example, 21 is higher than 10, 16, and 7. Therefore, is a peak. 31 is not a peak because it's higher than 7 and 16, but not higher than 32. And 32 is also a peak because it's higher than 31 and 14. But this problem doesn't state that we need to find multiple peaks. We need to find one peak, and that would satisfy the algorithm, basically. If we just need to find a peak, whatever it is, it doesn't matter. I don't want, when we are not going to constraints because it could get even more complicated, but that's basically what the algorithm is about. So First thing on, I broke that down before in pseudocode. The first step usually when we are working with divide and conquer is to find the middle of the data structure that we are working on. Yeah, in this case we need to find the middle column, uh, um, which can initially can be calculated by the length of the array, the start of the array, and divide by 2. Basically, we could not have the start of the array, but as we are working with divide and conquer, this strategy requires that we track the end of the data structure, and then we track the start and the end of the data structure, so we can calculate middle. Because what's going to happen is that the start and the end of the data structure will shrink as we go through the algorithm, as it but as each iteration goes by, we shrink this space that we are iterating, and that's why it's O log n, because we kind of we literally we reduce the time complexity for each iteration it goes by. So it's a very interesting way of looking at it. With that being said, finding the middle requires tracking left and right, and then dividing by 2. In this case, left is 0 because it's the start, right is the length, last one, which is the end, the foremost right item on the array, which is in this case, is here, right? And then we can find the middle column, which is in this case is 1, right? Okay, the second step in this case would be finding the global max on the middle column. Uh, so how do we find the middle max here? If we find the middle column, we are here in 5, 16, 31, and 31 should be the highest item. We need to find this guy because that's where we're going to. Uh, that's how the algorithm works. First need to start in the middle, and then we potentially want to find the highest item uh, in that column, so we can perform the necessary steps to find the highest item. So the highest item always go in the direction of the highest item, right? Um, and in this case, it starts first in the middle, and then we go right, and then we could go to right or to the left, right? So what happens is I need to build a function that will basically find the highest uh, item in this column. So what do I have here? I have an array, uh, and what I need to do is go through this array and find the index of the highest item in this array and return it to me. So for example, 31 is index 2, is O is 2, right? Um, how do I find the highest item here? How do I know where I am? So I know that I need to be on this column here. So how do I define n? All right, n will be basically the length of the rows. So the rows are basically 0, 1, and 2, right? So I need to loop through m, right? Accessing uh, basically the first item of. Um, so what I'm gonna do here, I'm gonna loop through uh, m uh, n times, right? So I can I'll be find max, for example, will be receive an m index, and a n number, and I will return an index, which is a number, right? And the matrix, right? Uh, that could be my function here. Find max would receive the matrix, the m index, which is the index that we are here, and we will receive n, which is the length uh, that we need to, which is highest from middle. So that gives us our position now. We have the highest and we have the middle, right? So now we need to check whether where we at is higher than is higher uh, than its neighbors 7 and 32. So we need to swap uh, the middle here, basically. So to find, we need to swap the the column, which is the last uh, portion of the matrix, and that would give us basically uh, this in this case. If we are at mat 2, 1 on row 1, column 1, row 2, column 1, row 2. Um, let's do that again. Uh, row 2, column 1, right? And we are here. I need to compare this with one left, and that should be left, and that should be right. And then if it is greater than its neighbors, what's going to happen is that it could be considered a peak, right? Because, and otherwise, if it is not a peak, what we do here, uh, if not, move the M lane, the middle lane, according the highest neighbor. So, for example, we are at 31, and we check if it's higher than the left. It is, but it's higher than the right. No, it's not. So we know that the foremost right have a highest value, and therefore we need to break down the search through that specific portion of the matrix. That being said, how do we do this? Now we have left and we have right, right? Those should be already tracked in our algorithm. And what's going to happen basically, uh, if highest is right, we're going to say uh, left is middle plus one. So that is going to be the left. Um, so what's going to happen here? Left comes to this way. Left is middle plus one, and left is now two because middle was one. Now becomes two, and we have uh, right is m plus one, and then we will have the middle calculated again and run the loop. So basically, what's going to happen? Left is two, and right will be middle, uh, will be m, which is length. So in that case, the length uh, is three, and three divided by two, so will be three plus two divided by two, which will be 2.5, which will be here. So we will sit here. This will be our middle, right? So middle now will come this way here. So this will be also the middle. We have this and have this, and will be also the middle now, right? Uh, and that should be our last iteration. And then we going to perform the same checks again, but now our middle is different. So what's going to happen on this iteration is the following. We're going to iterate through this column. So basically, we will run the function again, find the max row index, and we're going to pass the m index, which in this case is going to be 2, and we're going to loop at matrix 2 index and find the highest index. In this case will be 2, right? Um, and yeah, that's it basically. And then we'll find the highest item. Um, so yeah, that's basically the drawing board here. Let's go to back to coding. All right, let's get back into coding. Another day, another vendetta. Here's where we at. Let's get started. So first thing here, if we go back to the board, we'll see that we first define uh, the left and right pointers here, where you can say start uh, is 0 and is equal max 0 dot length minus 1, and then we can have like middle is equal uh, this plus this divided by 2, right? Then we'll have the middle, and after we have the middle, what do we do here? Um, we need to calculate the, so we need to create a function that will be get column max, which will receive the matrix and the middle index, and it will say like max index 0 and the value 0. Okie dokie. I think it's easier to do it with a single object, so I can just return the index after and also store the value while looping. So I can say for let I equals 0 and I lesser than say let rows number from let dot length. So we're gonna look through the rows. So and -1 row number plus and then we're gonna say if x dot value if at rows number middle is greater than max dot value x equal value is this, right? And get readable. Okay, repeat this. Right? So add first number column. Yeah. Then turn this. So if we run this with um, max middle is equal to max middle. Okay. What's going to happen here? Um, it's going to return in this case reset mat and reset the middle, which will be return 1, right? So what was going to happen? He will log to me. Um, 0, 1 and well, 1 and 3, right? I didn't add. Oh, 3 and 0. Very interesting. 3 and 0. Which number? Oh, because it's minus 1. Okay, so equals 0. Match rows number. 0. Oh, map index. Yeah, 1, 0. Matrix 0, 1, right? And then is 1, matrix 1. Mm, I don't like that. Yeah, that's it. JavaScript always free. Okay, that sounds good. Then we're gonna return the right thing here now. All right, cool. It's now 0. That's not what I want. Hmm, I should do. Okay, that's 1. That's the middle here. Now that we have the middle, we can just check if we don't have the max. We can check the left and the right and check if it is a peak. So basically what we need to do, check if it's a peak. And what we do is uh, if at selection actual current column max is equal max max is max in the middle, which is 1, and the index bar with 1, which is middle. So if I say this should be good here. For some reason it stopped recording, but that's the final result here. I messed a bit on the variables here, start and end, because I called them right and left. But yeah, submitted, done and dusted. That's a good leetcode problem, medium one. Uh, so that's that for Find a Peak 2. I hope everybody likes the problem solving skills. Uh, I made a few mistakes basically during the coding, which I kind of just mixed variables and uh, also I noticed that the highest calculation here wasn't quite correct, so I kind of needed to use an object to calculate this portion here, this function. I think those were the main mistakes that I noticed that I made here was the calculation on a function using index and not counting the sum, basically. And now, so another mistake, I kind of mixed columns and rows trying to access the matrix, which can be quite confusing. I could say that's because I'm ADHD, whatever. Uh, so, regardless of all that psychologic, neurologic stuff and these little mistakes, I think the problem was quite okay. I need to practice a few more times yet, but the main things here are navigating through matrices, uh, knowing that to use divide and conquer, aka binary search, we kind of use it on arrays. When using in arrays, we need to uh, kind of, have the control from what's the start and the end, the middle, and actually iterating while the end doesn't reach the middle. And this tricks me on JavaScript because length in JavaScript kind of sucks because it's -1. We have to set the loop correctly in JavaScript. But other than that, the problem is solved here. The logic and the data structure and the thought process is okay. I think that's valid for me at this video. So thank you guys, and later I'll be sharing more things about me and what I'm doing in my new interviewing process because I'm preparing to start doing interviews in the next year, and this is one of the steps that I'm taking to do that. I'll share later other channels that I'm following, reacting to those channels or reacting and also showing how I'm uh, researching how to find trustworthy resources on the internet to guide me in my studies. And because today the market is and the social media is flooded with loads of demotivated people, and they demotivated people even more. And I don't want to be on the chain. I want to be positive, and I will share with you positive influencers and positive content producers, positive developers that have their YouTube channel that help me and still help me today. So yeah, let's go, and I'll share that further. Thank you.